Okay, so this is continuing on to part B for linear algebra 2.1. Apologies for long delay. It's just this week has been particularly horrible for my schedule. So, anywho, let's get started. For 21, so let's just start from where we left off. 21. You guys should be able to see everything on here. So nothing too difficult. I just wanted to show you both ways as to how you solve it. So when you find the determinant of this 3 by 3 matrix, right? So one way is to use this thing called the sign chart, like that, right? So for 3 by 3, you just start with plus, minus, plus, minus, plus, minus, plus, minus, plus. We'll find out where that's really coming from, but we sort of talked about it already when we were determining the minors and cofactors and so forth. But we'll get more to that. So for now, this should be built in your head by now, since we're now currently doing 2.2 or 2.3, depending on which section you're in. So anywho, so determine A. So for me, again, when you look for these things, we want to find columns or rows with as many zeros as possible. If you see 0, 0, 0, that's a jackpot, but for most part, we just want to know, but most of the time, they'll either give you none or 1, and hopefully, if you're good at eliminations or, rearranging things, rearranging the rows and so on, hopefully the idea is that you'll get 2 zeros, and once you get 2 zeros, you only have, it will be much easier to calculate. So, as it will be shown over here. So, determinant A. So first, I circle this column for that reason, 2 zeros, like that, 2 zeros. So if I do here, so if I start with 0, I'm going to be looking at, so pretend there's like a line going through here, right? So I'm just going to be looking at 2, 1, negative 1, and 5, right? So what I mean by this, so here, that column, we're going to touch it, because we're using this guy, row, we're going to touch this row as well. So anything that doesn't touch, so 2, 1, negative 5, that's going to go right here, right? For that particular one. For number 5 though, because we're now looking at the second row now, right? So it's because of that, because the 5 is touching the second row, same column, right? So in that case, we're going to be using negative 3, 7, negative 1, and 5, as shown here. And we're just going to keep repeating the process, right? For the test purposes, we do not have to write this out, I don't think. It would be nice if you could, though, if you can afford such luxury, since you're essentially telling your teacher, I know what's happening. It's 0, but this is what it's supposed to be. So, but again, result-wise is inconsequential. So because 0 times anything is 0. So nonetheless, I cancel this one out. So all I have left is this. So 5 times, and everyone knows how to find that determinant for 2 by 2 by now, right? A times D minus B times C, right? So you have negative 3 times 5 gives me this, and then 7 times negative 1 gives me that. So that's gonna be 5 times negative 8, which will give you negative 40, and that will be your determinant. I know it's like all the way up there, but quite often the question will take that long. Question 22 is essentially the same idea. The only difference though is that I had to go through some minor elimination just to make sure that I have 2 zeros, right? Because you're not always going to get 2 zeros. If you could, that would be awesome, but nonetheless. So what I did was here, I explained what I did. I just times row, I used the row 2 to get rid of the leading coefficient for row 1 and row 3, as shown over here. So if I do that, then I get this, and from this, I'll use this column and say, okay, so this is how I will start calculating the determinant. So determinant A is, and this is another way. So remember here, we use sign chart. So remember, I haven't really mentioned this. Remember, like you wonder, okay, 0, 5, 0, I get where they're coming from. 0, 5, 0. Where is this negative 1, 1, and negative 1 coming from? Well, as we said, excuse me, 0 is touching this side. Excuse me. Okay, So this S entry happens to be right there, which happens to be negative sign. That's why we put negative. 5 happens to be on the 5 entry, it happens to be on that positive note. So that's going to be positive 1. And 0, negative 1. That's how it went, right? So this is how we use a sign chart. But there's another way to do this. I'd recommend sign chart simply because it's much easier to deal with. But there's another way, and this actually also explains why you have plus signs in this specific order. We'll find out why. So if we look at this one, determine A. So again, it's a negative 1. Is negative 1, but we have this thing, right? So that goes back to cofactor minor things we were doing in part A, right? So essentially, what's happening is, again, right, row plus column, right? So this 0 we're using is in row 1, column 1. So it's going to be 1 plus 1, which becomes 2. Any number to the power of 2 is going to be a positive number, right? So because of that, that's going to become positive. But nonetheless, that's the idea. And then we're timesing, so this essentially becomes a sign chart, right? If you think about it, right? Row, so row plus column, 1, 1, so that gives me 2. Anything to the power of 2 is going to be positive. If you look at here, it's going to be row 1, but the column will be 2, then it will be 3, right? 1 plus 2 is 3. If you have a negative number and you power it to 3, to odd number, then it's going to be negative, right? It's going to be negative 1. So, like for instance, if I have negative 1, and if I was looking at this guy, right, it will be 1 plus 2, right? Which gives me negative 1, 3, right? So that's negative 1 times negative 1 times negative 1 will give me a negative number, right? So, because of that, that's negative right there. So, basically, that's the idea. So, now you don't have to do this, so you could always just resort to star chart, right? Its pattern's pretty simple, right? Positive, negative, positive. Just keep going in that order, and then you'll get it, right? But be aware that this is also another way of calculating it too. And you need to know that anyway if you have to ever find cofactors and minors, just as we've been doing in part A. So, anywho, so you have that. And the second one's going to be 1. So 1's right here. That is going to be negative 1 to the power of 2 plus 1 because that's the second row and first column, so that's going to be negative number. So, and then I have the rest of this. And remember how we got this, right? So, going back here again. So if it's 0, it touches this first row and first column. So I'm going to be using 0, negative 4, negative 3, 9, as shown here. Same thing here. I'm touching this one, which touches the second row and the first column. So anything that doesn't touch, 3, 13, negative 3, 9, as shown here, right? And then you just repeat the process, and then you get negative 66. So, both ways. I'll be focusing on this method, but again, it really doesn't matter, right? So, okay, so I'll let you browse through that. For 23, I just said, okay, well, these are identical, so I can just choose one of the row, for my case, first row, and I just did elimination to get the second and third row all zeros. Okay, that makes it so much easier. So, I mean, I did it this way. I don't know why. I mean, technically, you could have done that way, right? So, because it has 3 zeros, and 3 zeros here as well. So, that would have been perfect, right? So, 0 times 0 times 0 is 0. But for some reason, I didn't do that, so we'll see how that, so what I chose was this column, right? So it's going to be negative 1, 1 plus 1 right there, right? So that's going to be a positive number, 1 times. So remember, this 1 is touching the first row, so it's 0, 0, 0, 0. Well, this is going to be 0, right? Right? Because 0 times 0 minus 0 times 0, so that's going to be 0. Rest of them is going to be times by 0, see? So because of that, I wrote it nonetheless, but it's, so because of that, it's going to be 0. Pretty simple stuff, right? Let's look at 24. 24 is a little bit complicated algebraically. Not that they're actually hard or anything, but please try 24. I can easily see how this might show up on a next quiz or and so forth. So it's only tricky because these entries are not very well defined. But just follow through it algebraically. Nothing new. Nothing new. Just just trying to crunch the algebra so that you get something like this. One of the tips that I got from Digby is that so once I got here, so basically I have all this, and then I'm gonna simplify further, right? I actually lined up like this, right? So anything to the power 3 goes in here, anything to the power 2 goes here, anything to the power 1, and just constant, right? That way they're all lined up based on their based on their what do you call that? Based on their degrees, I think that's what you call it. But so because of that, adding was so much easier. So when I added all this, I got that, right? By the way, that's not supposed to be minus. I meant to say this is equal to, but that's the idea. So again, nothing too difficult. Just make sure you don't get lost with the algebra and follow all these steps. That answer's I'm pretty sure all right. It's a right answer. So if you don't get this, then you did something wrong. So just try again. But honestly, same concept, right? So next one is 25. Yeah, and so it looks a little more intimidating because it's 4 by 4. But again, idea is the same thing, right? So here I got 3 zeros already. I could have made this easier, actually, now that I think about it, because there's 3 and -3, right? So I could have added 1 so that you have 3 zeros. That would have been actually better. But I didn't do it that way for some reason. So, but again, follow the same idea. So first I have 0, so we don't really care, right? But this -3 and 3 are not. So I have -3 and 3. And then, so this -3, it touches the third row. So anything that doesn't touch the third row and the third column, so it's going to be 3, 3, 5, 2, 2, -2, and 2, 10, 2. As shown here, right? And then, this one too it touches the fourth row. So 3, 3, 5, 2, 2, -2, 4, 1, 0. Right there. And then, so I'll let you just read through it. It's nothing new, so just keep going at it. And the algebra gets a little bit complicated because what happens is since it's 4 by 4, right? Once you find the matrix, you're still gonna have 3 by 3. We can't find a determinant of that easily. We can only do that for 2 by 2, right? So essentially, we have to do this again, right? So your solution book doesn't say it, but technically, we're finding a determinant of that, right? So that's gonna be just what we've been doing earlier, right? So you have I have 1 0 here, and so oh yeah. So I actually did some elimination here to get some kind of 0, but nonetheless, it's the same idea. So just follow through. It's a little confusing, but just follow through, and it'll be okay. When you have dimensions for this, right? Because we're finding a determinant of this, we're no longer looking at this guy. So here, for example, if I 5, so I chose this column, right? 5, 2, -2, 0. 5, -1 to the power 1 plus 3. So that's first column and first row and third column, right? So this dimension tracking ID or whatever, right? This has everything to do with these matrices, not these guys, right? For this matrices, we care about the size by showing here. So I'll let you browse that. I'll freeze the screen if you have to. Now that I've actually know a better way, let's see if this makes it easier. And still should give us the same answer, -2 or 40, right? So I'm actually going to try to do that right here. I'll leave the answer just to make sure. So then it's going to be, what I could do is I could say this is 3, 3, 0, 5, 2, 2, 0, -2. I have to get rid of 1, so it's going to be 0 and 3, let's say. So what I do, I added the fourth row to the third row. So that's going to be 6, 11, 0, and 2. And this is going to be 2, 10, 3, 2. So that's going to be row 3 is row 3 plus row 4. Right? So, now that I have that established, we're just going to keep going. So now that we can do this, right? So I could say determinant A is, I'm going to choose this column. So everything's going to be 0, so it's going to be 0 plus 0 plus 0, except the last one, which is going to be 3. 3, and then it's going to be negative 1. What's my size here? You have 4th row and third column, okay? And then it's going to be anything that does not touch here, right? So 4 and 3. So I'm touching 3, 3, 5. 2, 2, negative 2, 6, 11, 2. Okay, so don't care about these. Let's just keep going with this. So determinant A is still the same thing as 3, negative 1, 7, and determinant of that. Okay, so I'm going to actually change that. So same thing, determinant, but I will change this to, because I want 0 somewhere, right? So I want to get rid of that. So it's going to be 3, 3, 5, and 8, 13, 0, 6, 11, 2. Actually, numbers are getting a little big. Not that it matters, but just my. Okay, so so I thought maybe there's an easier way if I made 3 zeros. That way, if I still use this column, now I have 3 zeros rather than 2, right? So I got all these 3 zeros, all easy and stuff, but 3 still left. So I'm gonna use 3 and then do this, and then do this, right? So that's gonna be row 4, column 3, and then whatever matrix left over, right? So this is a row and the column I'm touching, so I'm touching all the entries that are not involved with this. So 3, 3, 5, 2, 2, negative 2, 6, 11, 2, which all goes right there. And then essentially what happens now is I just did a simple elimination to get 1, 0, right? So nothing new to that. And then basically I just do this, right? So so what I'm now doing is 3, negative 1, 7, that stays there, right? But now I'm going to define the determinant of this inner 3 by 3 matrix. So it's going to be 5, negative 2, and 0, right? Because we don't care about the 0. So 5, the same drill, right? So 2, 2, 8, 13. That doesn't touch this row, and then, so on, and vice versa. So that also should give you the same answer, negative 240. So again, nothing too difficult. It's just, you might want to be really comfortable with it because it can be quite a lengthy process, especially if you're not experienced. So that is that. In certain situations, finding a determinant is much, much easier, as we will look at in a section for sorry, let me say that again. In this particular section where they deal with question 27 to 30. There's a special rule for certain matrices, as we will be seeing right now. Okay, so this is where it gets a little interesting. So the one thing you want to focus on is your theorem. So according to theorem 2.1.2, it says if A is a specific matrix with an exact same dimensional size, so n by n, so it's gotta be like a square, right? Essentially, so the rows and the columns must have the same length, and has the upper triangle or lower triangle or diagonal triangle. Now, what do these three terms mean? Upper triangle simply means like this, right? So if you make a diagonal line, on the top all the integers are 0. So see here, so that's what I'm talking about, right? Hopefully you guys can't see it really well. Okay, maybe not. But so you have 2, 2, 2 here, right? So basically, anything on top of that, there must be all 0. So we call that upper triangle. Lower triangle, same thing. So again, these three diagonal line, right? Anything below that should be all 0, 0, 0. So that's what's called lower triangle. But wait a minute, for question 28, there is upper triangle and lower triangle. So when you have both of those, we call that diagonal triangle. But nonetheless, it's the same idea. So we want to make sure there's at least top or the bottom of the diagonal line is going to be all 0 entries. And that's the characteristics you see all here. So here is a diagonal triangle, diagonal triangle. This one isn't quite a diagonal triangle because it's not 0 on both sides. It's like this is the center here, right? So here there are some of them are not 0 entries, but on top they are all 0 entries, right? So that for that case we won't call that a diagonal triangle. We're gonna call that upper triangle. And if you look at this one, my diagonal line is here 1, 2, 3, 4. On the top, no, there's no 0, and they're not all exclusively zeros, but on the bottom it is. So we call this one lower triangle. So that's the idea. So the point is you have to try to remember this condition, because if you do, it could really help you out for some of the tricky questions. So because what's so special about this condition is that if you have this condition, you can just simply multiply all the entries in the diagonal line, and then that will just give you the determinant. So that's a nice shortcut. So for example, here we already established the condition, so it's going to be just 1 times negative 1 times 1 gives me negative 1. Same idea with this, right? For this one, it's 0. Why is that? Because we have that condition, so we could just times everything on the diagonal line. But 1 is 0. 0 times 2 times 3 times 8. Anything times 0 is 0. Perfect. And the same idea goes here. Here the middle is 1, 2, 3, 4, so it's going to be right. So yeah, so this is so much easier than all the stuff that we've been doing in the past, right? So if you can find this if you can identify this condition, and maybe you have to do some eliminations or play around with the matrix so that you can maybe get to this one of these formats. If you could do that, all hats off to you, right? But so just know that this option is out there, and this may be useful for other questions in the future. So that wraps up 2.1. We'll try to upload 2.2 as soon as I can, but yeah, so this should cover all the materials for upcoming test quiz 2, I think. Anyways, so I will also be uploading the practice test, but that's all there is. Not too difficult. So yeah, so we'll see each other again for 2.2.